Guys, I am super excited because we are almost done. Like, you've made it almost all the way to the end. This is the last section of stuff that we're going to do this quarter, and it's all a whole lot easier than everything that you've had to do so far. So I'm really proud of you for working so hard and getting here, and I promise you that from here on out, things are going to feel nice and easy. So in chapter 20, we're going to be studying carbohydrates. And this first section, 20.1, Introduction to Carbohydrates, we're just going to define them, carbohydrates, and look at some examples of different types of carbohydrates. Carbohydrate is what we would commonly call a sugar or a starch. So this would be like in terms of nutrition. Carbohydrates contain, speaking as a scientist, contain either a ketone functional group or an aldehyde functional group. And if you forgot what those are, don't worry, because we'll review them. And they also contain, in addition to having either a ketone or an aldehyde, they also contain alcohol. Sometimes many alcohol functional groups. Carbohydrates can be classified 3 different ways. So every carbohydrate can be classified in one of 3 ways. We have monosaccharides. We could also classify them as a disaccharide. Or a polysaccharide. In the classification, mono versus di versus poly is based on the structure of the carbohydrate. So let's just look at some characteristics of each of these. Mono, the prefix mono means 1, as you know, and saccharide is our term for sugar. So monosaccharide translates to 1 sugar. It is a single sugar molecule. Disaccharide translates to 2 sugars, because di is the prefix for 2, and poly, as you know, is the prefix for many. So this would be translated, it would be many sugars. But for us, it's going to be 3 or more. Although usually our polysaccharides have like a ton. Our sugars either have 1 monosaccharide, or it's 2, a disaccharide, or then like the next option is like 200 or something. So there's not a lot of 3s or 4s or 5s. A monosaccharide is what we call a simple sugar, which means that when we ingest it, when we put it in our body, we don't break it down into a smaller sugar. We can break it down into something totally different, but we can't break it down into a smaller sugar molecule. The disaccharides, our body can, well, not all, but our body can break disaccharides down into 2 monosaccharides. And that is going to be the way that we metabolize the disaccharide carbohydrates. And like I said, some disaccharides our bodies are not capable of breaking down, and so we can't metabolize them, which we'll talk about. And then a polysaccharide, if we can digest it, it can be broken down into 3 or more, depending on how big it is, monosaccharides. Some examples of mono and di and polysaccharides. Glucose is a monosaccharide. and so is fructose. Some examples of disaccharides: sucrose and lactose. Some examples of polysaccharides, well, actually I'm only going to give you one right now: starch, monosaccharides typically, so we're going to call this typically, have 6 carbons in them. And that's just because the most common monosaccharides that we encounter in nature are 6 carbon monosaccharides, but we are going to look at examples that have less than 6. So 6 is going to be the maximum number of carbons. Maximum carbon is 6. Disaccharides typically have 12, which should make sense because a disaccharide is 2 monosaccharides. So if a monosaccharide has 6, then a disaccharide needs to have 12. But again, that's really a maximum for a disaccharide. A maximum number of carbons would be 12, and we can have some that have less than that. And then polysaccharides are going to typically have hundreds of carbons. So in terms of the structure, like how will you know you're looking at a disaccharide if you see one? So one way that we represent disaccharides is this up and down. Like instead of drawing it on its side, it ends up taking a lot of space up on our paper. This up and down chain of 6 carbon atoms, which I've drawn right here, 1, 2, 3, 4, 5, 6, with an aldehyde group up top. So just in case you forgot what the aldehyde group looks like, the aldehyde group is a carbon-oxygen double bond that has a hydrogen attached to it. That's our aldehyde group. And then going down the carbon chain, our many OH groups. So this is kind of shaped like a Fisher projection, but I'm not drawing it in the standard Fisher projection notation because I'm showing all the atoms. And then down here at the end, we are going to write CH2OH. And this is pretty normal notation where along the middle of the carbon chain, we're drawing out the C and the H and the OH bonds to show, in this case, all of them are on the right-hand side of the carbon chain, but we do want to show the position, left side versus right side. And then also it's very standard for the very bottom of this chain for us to just condense it up, CH2OH. And not show the bonds in that case. So this would be a typical representation of a monosaccharide. Another typical representation of a monosaccharide is to draw it as a ring. So when we draw it cyclic or as a ring, the structure gets kind of crazy. Now we're going to go through these ring structures of monosaccharides. So as we're drawing this right now, don't let your head explode because it's not as tricky as it looks. And we're just kind of copying this down in our notes right now. But we are going to explain this particular monosaccharide structure, this version of the monosaccharide, why we can have a straight chain and also a cyclic monosaccharide, like what that's all about. We'll get to that. But you can see with a monosaccharide, what we're looking at in general is either a straight chain, like this representation right here, a straight chain, or a single ring, just one single ring. So let's talk about disaccharides now. Disaccharides, when we're looking at a disaccharide, we're not going to ever represent it in a straight chain form because they never exist that way. So we're only going to be looking at disaccharides in a ring form. And we're going to draw another ring molecule here. And again, don't let this intimidate you because we are going to go over where these rings come from Actually, I don't want to put that H up there. Change my mind on that H. We're going to go over where these rings come from, how to draw them, how to interpret them, what they mean. They're not as hard as they look. So when we are drawing a disaccharide, because it is 2 sugars, that means we're going to have 2 rings. I lost a carbon in my drawing. And I am really bad at drawing these 6-membered rings on their sides. And I'm not totally sure why I can't draw them pretty when they're on their sides. So here would be a disaccharide, and we know it's a disaccharide because it has 2 rings, like that. This particular disaccharide is lactose. Now, it's not going to be important for you to look at the structure and know that it's lactose, or for you to be able to, like if I say lactose, draw it or pick it out. That's not going to be important. So I'm just telling you this FYI, it's lactose. Lactose, when we consume it, our body digests it by breaking it apart at this point of attachment of the 2 rings. And when we break it apart, we end up with 2 monosaccharides, and those monosaccharides are glucose and galactose. So these both, glucose and galactose, both of these are monosaccharides. Screwed up the monosaccharides. Monosaccharides that our body produces when we digest lactose. Sucrose, which I also put on your list as a disaccharide. Sucrose, when we digest it, our body breaks it up into glucose and fructose, both of which are monosaccharides. So there's disaccharides, and then last but not least, let's talk about polysaccharides. Now, with polysaccharides, we're not going to draw a picture in our notes of polysaccharides because they're pretty big. We are going to look at the structures of polysaccharides when we come to them in this chapter. So all that I'm going to really say in terms of polysaccharides, starch, when starch is digested, it breaks down to anywhere from hundreds to thousands, depending on how big the starch molecule is, hundreds to thousands of glucose molecules. Another example, actually I want to put one more. Another example of a polysaccharide is glycogen, which is also made up of glucose molecules. So this is just your introduction to carbohydrates, and what we're going to do now is go through the 3 monosaccharides, disaccharides, and polysaccharides and talk about them in more detail.